So now we are going to look at some of the bivariant analysis, in which we are going to take two features at a time, and we will just see that what is the relationship between those features. So you can see I have taken income column and the total spent column, and onto that we are just looking at a scatter plot. So this is a total spent we have, and this is the income we have. So you can see now, when there is an increase in income, there is always increase in total spend. That's the natural thing that we all human have, and that's the same thing that is representing here. But there is one more thing to notice here, that I have applied some of the hue. So you can see these are the hue that I have applied. So now what is happening here, that is actually called subcategorization. So whatever the scatter plot that we are having, it is between the relationship of total spent and income. So each dot here is representing the two values, like a pair of values. You can say the coordinate, which is having total spent and income value. But if you have applied hue, what is happening here, first of all it is applying hue on education. So you can see it is sub categorizing the plots like a scatter plot. So you can see for the blue dots we are having only graduate persons, for orange dot we are having postgraduate persons, and for the green dot we are having undergraduate. So you can see, you can easily observe the green dots here. Even if the income is increasing, the total spent is actually same. So why this is happening, because undergraduate persons have no any source of income, so that is why even the pocket money is increasing, so total spend is actually constant. But for most of the people which are having graduate and postgraduate, so the total spend is actually increasing with the income as increased. Now again you can see the hue with the marital status. What is the difference between like married and unmarried people? So you can see like there is not much difference, like there is a random value that we have, so there is no any clue that we can make out of that. So that is the same thing. But if you can see, there is a much difference in that case if you are having is kids. So if there is a kid, that means represent 1. You can see orange dot we have, and this is the blue dot we have. So you can see, you can observe that there are very few values which are having kids, and which are having like these portions are here. And you can see that even if the income is increasing, mostly the total spend is not much for these cases. There are few cases we are having, but not much. But for the persons which are having 0 kids, the mostly the total spend is increasing with the income. Again there are some relation between early accepted campaign. So if there is a person which has accepted the early accepted campaign, like having value 1, so you can see most of the dots are here. So the person which has accepted the early campaign, so the person which are accepted the early campaign, you can see most of them are having high income and high total spend. So these are the things that we can observe out of that, and I will also show you what are the observation points that I have made out of that. And there is another scatter plot that we have made. So we just want to see what is the difference between essential and non-essential spend in terms of distribution between income and spend. So this is the distribution that we have. So you can see these are the some of the conclusions that I have made. And it is very important, whenever you are doing any analysis, you are plotting any charts and graph, I would suggest that you must always make some conclusion point out of that, because just looking at the graphs, no one will going to understand it what is actually you want to represent, because there are so much of graphs and charts that we are making it here, so it will be confusing for a person. So we need to make some of the conclusion points, so that by just looking at the graph and hearing at the conclusions, he can easily understand that what you actually want to show. That means what's the result that you have find out. So you can see some of the conclusions. For undergrad customers, the income as well as spent is very low, while the for graduate and postgraduate customers, the distribution is nearly same. So there are the things that I have observed. There is not much effect on the income and expenditure distribution for married and unmarried people. For most of the family having kids, the income and expenditure both are low, while the family having no kids, it is high. One of the observation is that customers who accepted the campaign earlier are having high average income as spend. So this was the things that I have already mentioned you. So it's important to make all of these conclusions. So next we are going to look at some of the distribution between the income and spend, income and spend, sorry, with respect to age. So if the age is increasing, is the income increasing or not. So we are taking the graph between income and age, and again total spent and age. So you can see if the age is increasing, there is always a increase in the income. So as the experience increases, there is always a increase in income, and with respect to income, again the total spent is also increasing. So there are some spike value that are high peak value that we have, but you can just ignore that thing because there might be very less data, so that like the distribution is not showing the correctly. So you can just take the mid-range distribution that we have, and it will just give you the trend. So let's see how the number of days customer engaged with the company affect the purchasing power. So you can see if we take the scatter plot between total spent and day engaged, there is not much quite any relation that we can get. So it is actually totally random graph that we are getting. So this is the random scatter plot, and there is no relationship between total spent and day engaged. So even though there is a customer which is having very long day engagement, there is not necessary that the total spent will be more for that thing. Now that was a scatter plot, but you can see the same thing in other way also. Like you can take the distribution between total spent and income, and you can take that day engaged as a legend, and you can just take the like CMAP as a seismic. So it will just give the values like day engaged value, you can see 0 to 1000. So if there is a high value, it will be red. If there is low value, it will be blue. So you can see these are the distribution that we have. So from here you can just see that if there is a high like this region having red value, so that means day engaged is more. So for those people, you can see that this is coming left side, that means the income is less but spent is more for those people. But in the right side you are having more blue dots, that means having less day engaged. And yeah, total spent is also high, like distribution is same, but this is coming on the left side, that means the average income is less for these kind of people, but average income is high for blue dots. So that's the conclusion you can make out of that. Now one thing I will say, that whatever the graphs that you are looking at here, graphs and charts and scatter plots, whatever I have made, so you might be confused about the syntax, how this has been generated. So I would say that it is not necessary to remember all the syntaxes of generating the graphs. You can just have an idea that what kind of graph you want actually, and then you can just search on the Google. You can take the help of like chat GPT or AI, and you can just generate that code to generate that kind of graph. But if you understand the basic syntax of generating the graphs, you can easily understand that code, and you can easily like manipulate that code based on your preferences and choices, and you can just use that code for your purposes. So that was it from the bivariant analysis. Last we are going to look at the correlation analysis. So what is exactly correlation analysis? That instead of taking each of these two features and creating graphs between them like scatter plot, and looking at the relationship between them, like it is having relationship or not, we are going to make a correlation heat map in which we are going to look at all of these columns at a time. Like this is the columns that we have, and this is the same column plotted horizontally we have, and it will make the pair of each of these features like late accepted campaign and income. So this is the pair that we have, and the value that is representing like 0.24, it is representing how much they are correlated. So when you see the graphs, whatever the graph that you have seen here, like take that example of this one, you know that there is a relationship between total spend and income. So by looking at the graph, you can say that there is a relationship between total spent and income, obviously, because you can see the graph, if the income is increasing, the total spent is increasing. But this is the just qualitative way of saying that. But if I ask you how much they are correlated, like the quantitative way, how much they are correlated, so that answer lies here in the correlation heat map, and I have already explained that thing in the previous session also. So if there is a like high correlation value, let's say 0.79, so total spent and income, you can see now why there is a high correlation that here, because the value is high, total spent and income. So by looking at the graph, you can see that there is a correlation between them, but how much they are correlated, that heat map will give you the value 0.7. So that means there is a too much correlation between them. Again you can see the total spent and the non-essential spent is actually highly correlated. Why? because that's the same thing, total spent is actually what, the sum of essential and non-essential spent. So it is actually derived features, that is why this is having a high correlation. So based on the correlation heat map, you can essentially look at the correlation between each of these features. And if you are having any machine learning model that you are going to apply, so if you are having any column that is the target variable, so you can just look at the features which are having high correlation with the target variable, and you can filter that features only to train your model. So that will be like future thing that I'm saying. So whenever I'm going to teach you the machine learning part, I'll be showing you actually how we can use that thing. So that is it, guys. That was the last thing that I have shown you. So this is how you can do exploratory data analysis on any kind of data. So we initially had no any like predefined matrix for doing the analysis. So this was a random analysis that we have done, because our aim was not to find some of the predefined matrix out of that, but our aim was to just observe the data set, handle the null values, handle the outliers, and then create new features out of that, and look at the distribution of each of these features and how they are correlated to each other. So our aim was basically to analyze the features so that we can use that features for the customer personality analysis, in which we will do actually clustering. But it might be the case when you are having the data set and you are having predefined matrix, like for example someone has given you data set and they want to find out the top 5 products which are having the most profit or which are having the lowest profit, that kind of thing. So this is actually called predefined matrix for your data analysis. But my aim was here to just show you what kind of charts and graph and analysis you can do, how you can handle those null and outlier values, and how you can create new features. Since you have learned all of these things, now I can give you a capstone project based on the EDA. So if you haven't joined the WhatsApp community, join there. I will give the capstone project there, in which we will be having some of the predefined matrix. So I will try to give those kind of analysis in which we will be having some of the predefined matrix to find out and observe the data. And if you submit that assignment to me, I will also evaluate them and give the feedback that how you can improve on them. And at last I will also make the video on that capstone project, that how we can do that analysis in a right way. So that is it, guys, from this session. We'll meet in the next session. Till then, take care. Goodbye.